Okay, topic 4 is over key features of functions. What you will learn from topic 4, look at the equation of a function. You should be able to identify domain and range and possible asymptotes. Looking at the graph of a function, you should be able to identify domain and range, asymptotes, x and y intercepts. So the functions that we will look at the linear functions, quadratic functions, and even nth power functions, cubic and odd nth power functions, square root and even root functions, and cube root, odd root functions, absolute value, exponential, logarithmic, and we will also look a little bit at rational functions. I will also post another rational functions video going more in depth on just graphing features of rational functions and some of the different types that you will see. So for linear functions, that's whenever it's just a straight line. And we really have three possibilities. We have the possibility of a vertical line, a horizontal line, and a diagonal line. And so a vertical line is when it's just x equals, horizontal is when it's y equals, and diagonal is when it's y equals with some x value as well. So vertical line, that's when it's just x equals a number. And for that, the x can only be whatever specific number the equation says. And so for your domain, it would just be x equals that specific number. But that is a line that hits every single y value. So y is every number possible. So your range is the y value. So it would be all reals. So if you're looking at this vertical line, right, your domain, that's your x value. So in this case, my x value is -2. So my domain is x equals -2. And again, my range, that's all the possible y values. And when you look at this arrow is going up. So I know I'm continuing in the y positive direction. So infinite number of y values. And I'm continuing in the negative direction, infinite number of y values. So all possible y values can work. So my range is all reals. My x-intercept is where I'm crossing the x-axis, and that's at -2. My y-intercept, where I'm crossing the y-axis, because this is a vertical line, it does not cross the y-axis. So there is no y-intercept. And there's also no asymptotes. If you see a graph, the asymptotes will be noted as a dotted line or a red line showing that there is some boundary that your graph approaches but does not touch. So if you do not see something showing otherwise, then looking at a graph, you don't have any asymptotes to identify. For a horizontal line, that is when all x numbers are possible. So your domain would be all reals, and then the y values would only be able to be whatever that specific number is. Y equals that same number. And so for this horizontal line, right, my domain is my x values, and it's going left forever, right forever. So that domain would be all reals. And then your range, that's your y value. And so this is hitting the y-axis at 3. So my range would be y equals 3. For my x-intercept, that's where I'm crossing my x-axis. This line is not crossing the x-axis, so there is no x-intercept. And my y-intercept, where I'm crossing the y-axis, is at y equals 3. And again, I do not have any asymptotes for this function. And then we have diagonal lines. And so for a diagonal line, when you're talking about domain, what values of x could you plug into this? Could you plug in positive numbers? Can you plug in negative? Can you plug in fractions? Can you plug in irrational? Like, could I replace this with pi? And so because this doesn't have any restrictions on what you can plug into it, my domain is all real numbers. And so because I can plug in every single possible x value and there's no change in the y value, then my range is also going to be all reals because I could get out every possible y value. And so my domain, that's my x values. These arrows go left and right forever. So your domain is all reals. They're also going up forever and down forever. So your range is all reals. And for your x-intercept, where you're crossing the x-axis, that's at x equals -2. And for the y-intercept, where you're crossing the y-axis, that is at at y equals +2. And I don't have any dotted lines or red lines around here, so I do not have any asymptotes. And this is another linear diagonal function. It just has a negative slope. And so your domain is still all reals. It's still going left and right forever. And your range is still all reals. It is still going up and down forever. And your x-intercept, where you're crossing the x-axis, that's at about -1.5. And your y-intercept, where we're crossing that y-axis, is at about -3. And there's no dotted or red lines around, so I do not have any asymptotes. Next, we have the quadratic function, which is the shape of a parabola, that U shape. And so we're going to look at two different possibilities, positive x squared and negative x squared. And so these characteristics can also hold true for any even power function. So x squared, x to the power of 4, x to the power of 6. So for the positive x squared, or just y equals x squared plus k, your domain is whatever x values you could plug into this. And so I can plug in any possible x value. I can plug in a negative, a positive, a radical. I don't have any restrictions on what numbers I can plug in here. And so that would make my domain all reals. But when you are squaring a number, it is always going to become positive because two positives multiplied together stay positive, and two negatives multiplied together become positive. So no matter what x value I plug in, my y value will become positive. And so that k is what can adjust it. If I scoot that graph down a little bit, then I may end up with some negative y values. And so this is what sets that boundary if we shift at all. And if there's no shift happening, then the k would be 0. So that range would be y greater than or equal to 0. So here's the positive one. And so domain, it's the x values. It goes left and right forever. So that is all reals. My range, my y values, I have that stopping point down here, that bottom of that parabola at -2. So my y value is going to be everything greater than or equal to, because I'm touching at that point. So y greater than or equal to -2. And then my x-intercept, where I'm crossing that x-axis, I have two of them. I have one at about -2.5 and another at about +0.5. And then for my y-intercept, where I'm crossing the y-axis, I have a y-intercept at about -1. And there's no dotted or red lines around, so I have no asymptotes. And then for the negative x squared function, when that negative symbol is in front of the x squared, I can still plug in any x value that I want to. And so that will give me all reals for my domain. And so in this case, because I am taking whatever number I get that is squared and making it negative, then my y can only be negative. And so if that k value shifts that function up or down, then that will change my range. And so in general, your range is y less than or equal to 0. And then if there's a shift, that is that new number you would write for that range. So this is a negative quadratic function. So your domain, I'm going left and right forever. So your domain is all reals. And your range, your y values, I have a maximum y value right here at +5. So my range is all the y values less than or equal to +5. My x-intercepts, where I'm crossing the x-axis, I have an x-intercept right here at about 0.75 and right here at about 5.25. And for my y-intercept, I have a y-intercept down here at about -4. Again, no dotted lines, no red lines, so I have no asymptotes. Cubic or odd power functions, that's when the ends are going in opposite directions. So this is where those polynomial function characteristics come into play a little bit. And so because they are odd root powers, I can still be plugging in any x value that I want. It's all reals. But because it's that odd root number, I can get out negative or positive values depending on what I plug in. So that range is also going to be all reals. And so if you're looking that line to the left, it's going down and to the left. This one's going up and to the right. So I'm going left and right forever. So your domain is all reals. And I'm going up and down forever. So your range is also all reals. And for my x-intercept, where I'm crossing the x-axis, I have one at x equals -3. And for my y-intercept, where I'm crossing the y-axis, I'd be crossing at y equals 8. And there is no asymptotes that are happening on this graph. Okay, this is a negative function. The domain and range are going to stay the same. It's still going left and right forever, so all reals. Up and down forever, so all reals. The x-intercept, where you're crossing the x-axis, that's at about -0.25. And your y-intercept, where you're crossing the y-axis, that's at about -1. And no dotted, no red line, so I have no asymptotes. Square root and even root functions, those are the half sideways parabolas. And so we have two possibilities. We have the positive square root of x and then the negative square root of x. And so for positive square root of x, you can only have positive inputs. And so in general, input means x value. But when we're talking about a function, input can have to do with where the numbers are going. And so your input is what you're putting into this radical. And so x minus h is what is inside that radical. So I need to make sure that whatever is in this parentheses right here is a positive number. I can't take the square root of a negative number. And so for that to be possible, then my x values would have to be greater than or equal to h. If it was equal to h, then I would get a 0, and I can take the square root of 0. And if it's greater than h, then that's going to make sure that this parentheses stays positive. And so for my y values, because I can only put in positive x values, I will only get out positive y values. And so your y values are just going to be whatever is dependent, whatever's y greater than that k value, however you're shifting. So your domain, it's the x value starting right here. So it's x greater than or equal to -2, because it's everything greater than that, everything to the right of that number. And then for my range, it's everything greater than or equal to that y value. So greater than or equal to 0. And for my x-intercept, where I'm crossing the x-axis, that's happening at -2. And for my y-intercept, where I'm crossing the y-axis, that's happening at about 1.5. And I don't have any asymptotes drawn, so there is none for this function. And then for negative square roots, my domain still has to be all positive values. Whatever I'm plugging into this radical function still has to stay positive. So my domain does not change. But now my range, I can only get negative outputs because I take all of those positive numbers and I take the negative of them. And so it's everything less than that k value, that shift. So your domain, that's your x values, that is going to be everything greater than, because it's going to the right, and we're starting at 0. So x greater than or equal to 0. And for your range, that's your y values, that's going to be everything less than, because we're going down, less than or equal to 0 for the y's. My x-intercept, where I'm crossing the x-axis, that's happening at the origin. So my x-intercept is x equals 0, and my y-intercept is x equals 0. And I have no asymptotes for this function. Cube root and odd root functions. That's when still your ends go in opposite directions, still like the cubic or higher power functions. And so when you are talking about these, when you take the cube root of a number, you can take negative cube roots. So you can plug in any x values. So your x values will still be all reals. and you will still be able to get out any y values. So your y value, your range, will be all reals. Okay, so my arrows are going left and right forever. That tells me my domain is all reals. They're also going down and up forever, so that also tells me my range is all reals. And for my x-intercept, my y-intercept, I'm crossing at that origin, so x equals 0 and y equals 0. And I do not have any asymptotes for this function. This is the negative cubic function, and so my domain and range do not change. I'm still going left and right forever for domain of all reals, and up and down forever for a range of all reals. My x-intercept and my y-intercept are still at that origin, so x equals 0 for the x-intercept, y equals 0 for the y-intercept. And for my asymptotes, there's no dotted lines or red lines drawn, so I do not have any asymptotes. Okay, absolute value functions, those are the ones that are shaped like a V. So we're going to look at the two cases, the positive absolute value and the negative absolute value. So for positive absolute value, you can plug in any number you want into that absolute value function, but you will only get out positive values when you plug those numbers in. And so because this sign stays the same, I can still only get out positive outputs, only positive y values. And so it's going to be y greater than or equal to k. That's going to be that shift if I go up or down any. And so for this one, your domain, I'm going left and right forever. Your domain is all reals. My range, I have this minimum at 2. So it's y greater than or equal to 2. My x-intercept, I'm not crossing this x-axis anywhere. So this does not have an x-intercept. And my y-intercept, that's happening right there at that vertex, that y equals 2. And still no dotted lines, no red lines drawn, so I have no asymptotes. For a negative absolute value, I can still plug in any x value that I want. It can be all real numbers. But because no matter what I plug in, this will always be positive, I then change it to negative. My y values can only be negative. So y has to be less than or equal to k. Okay, so for this one, domain, I'm going left and right forever. That's a domain of all real numbers. And for my range, that's going up and down. And so my maximum value is y equals 0. So I want everything less than or equal to 0. So y less than or equal to 0. My x-intercept, I'm crossing right there at that vertex, x equals 0. It's also my y-intercept, y equals 0. And no dotted or red lines, so I have no asymptotes. Exponential functions, that's whenever it's got a steep curve. And so we're going to look at the two possibilities, a positive exponential and a negative exponential. So positive exponential, you can plug in any x value that you want, positive or negative, it does not matter. It's all real values. But no matter what values you plug in for x, I will only get out a positive b value if this is a v. So I will only get positive y values, and I can't get a value of 0. If I have a 0 here, then this becomes a 1. And so nothing can be equal to 0. And so for these functions, we do have asymptotes. And so my range, that k value is that asymptote, and my range has to be strictly greater than. We are not touching it at that k value. And so this right here, this red line, that's that asymptote. That would be the k value. And in this case, there's nothing, it's a 0. This is a y equals 0 equation. And so with k equals 0, that's when there's nothing written there. Okay, and so your domain, that's your x values, that's going left and right, and that is happening in both directions. So your domain is all reals. But my range, I'm going up forever, so it's going to be all the y's greater than whatever the lowest is. And I keep getting closer and closer to this asymptote at y equals 0, but I never hit it. So it has to be everything greater than. It can't be equal to because it never hits it. So y greater than 0. And so for my x-intercept, because that is my x-axis, is my asymptote of this function, I do not have an x-intercept. My y-intercept is happening at y equals 1, and then that asymptote is happening at y equals 0. And so your asymptote and your range will relate to each other for these exponential functions. And then for negative b values, I can still plug in any x value that I want, but no matter what, this would have still been a positive function, and so I take the negative. So my y values will all be negative. So y has to be less than my k value. And so I still have that horizontal asymptote. In my domain, I'm still going left and right forever. My domain is all reals. My range, I'm going down forever, so it's going to be everything less than wherever this line approaches, and it's approaching at 0. So y less than 0. My x-intercept, where I'm crossing the x-axis, that's still this asymptote, so I do not have an x-intercept for this graph. And the y-intercept, where I'm crossing the y-axis, that's happening at y equals -1. And that asymptote is at y equals 0. And again, that range and asymptote, those numbers relate to each other. So for logarithmic functions, we still have two possibilities. We have the positive log functions and the negative log functions. So for this type of function, I can only have positive inputs. And so this is where the x minus h function is. That minus h goes as the input to the log. And so that whole piece would have had to have been positive. So I have to make sure that my x is greater than h. And so for this function, I cannot have an input of 0. That is undefined for log functions. So it has to be strictly greater than h, because if I do not have an h value, that would have been 0. So x greater than 0. But I can have any output. So my range is going to still be all reals. So domain, the smallest x value I can approach is 0, and it's going to be all the x values greater than. So strictly greater than, because I have this red asymptote here. So x greater than 0 for my domain. And for my range, that blue line is going down forever, and it's also going up towards the right forever. So my range is going to be all reals. My x-intercept is going to be right here at x equals 1. And my y-intercept, my y-axis is my asymptote for this function, so I am not crossing that y-axis, so I do not have a y-intercept for this function. And so for my asymptote, that would be at x equals 0. When it's a line going straight up and down, you write it as x equals. Then we have the negative log functions. Those inputs can still only be positive, so x has to be greater than h. And I can still have any output, so all reals. So this didn't change much, that domain or range, except for just that sign. So this is going to be greater. No, this should be, yes. So for this function, my domain is going to be everything still greater than that asymptote, x greater than 0. My range is going to be those y values. It's still going up forever and down forever, so all reals. My x-intercept is at x equals 1. I do not have a y-intercept since my asymptote is the y-axis. And the equation for my asymptote is x equals 0. So when I flipped these, that positive and negative exponential or log functions, it didn't change the domain and range any. We can never have those negative x values happening because it would make that log function undefined. So for rational functions, it's a little bit more complicated finding that domain and range. And so to find your domain, you can plug in any x value that does not make the denominator 0. And so for the domain, it's when that denominator is 0, that tells you what your asymptote is. And so x cannot equal the asymptote is how the domain is going to be written. So you can get out any input besides what would come from that excluded x value. So whatever x value you can't plug in because of the asymptote, I could also not be able to get that matching y value out. Okay, so for my domain, that's my x values. And so domain, it's just excluding that asymptote. And this is that vertical asymptote at -2. So I can have every number to the left of it. This is going all the way to the left, and every number to the right of it. I just cannot have an x value of -2. So my domain is just x not equal to -2. You can also write it as all reals with x not equal to -2. There's a couple different ways that it can be written. And then for my range, it's going to be the same idea. It's those y values. I'm going down forever, but I cannot cross this red line. So I cannot have a y value of -3. And then I continue up forever. So my range is just going to be y cannot equal -3. And for my x-intercept, where I'm crossing the x-axis, I have one right here at -1. And my y-intercept, I have one here at -1.5. This function is not going to cross either axis because those asymptotes keep it from happening. And so then the equations of my asymptotes, I have a vertical asymptote at x equals -2. And then I have a horizontal asymptote right here at y equals -3. Okay, and so this is a negative rational function. And so your domain is still just going to be all x values except for that red line right there. So that's going to be at +3. So my domain is x not equal to +3. And then my range is going to be all of those y values except for that red line right there, that boundary, that asymptote. So that's at -1. So my range is going to be y not equal to -1. X-intercept, I have an x-intercept here at +2. And then a y-intercept, I have a y-intercept right here at about -0.75. And then for those asymptotes, I have a vertical asymptote at x equals 3 and a horizontal asymptote at y equals -1. And so those domain and range numbers should match up with those asymptote numbers. Okay, so when you are looking at other types of rational functions, there's ways to identify the vertical asymptotes. And so a vertical asymptote occurs in a rational function when that denominator is equal to 0. And so in order to solve for that vertical asymptote, you set the denominator equal to 0 and solve for what x is. And then that tells you that excluded value. So for this first function, I'm going to set that denominator equal to 0 and solve. So I have 2x squared minus 18 equals 0. And so our goal is to solve for that x value. And so in order to do that, we're going to have to factor this equation. And if you're needing more help in factoring, I will have a supplementary video that is posted sometime this week. And so looking at these two pieces, I know that one of the numbers they both have in common is a 2. And so I can factor a 2 out. And that leaves me with x squared. I took 2 out of this, and then -18 divided by 2 leaves me with a -9. And so this is a perfect difference of squares. So I know from a shortcut that we learned that this factors into those opposite signs of the same square root. So that 2 factored out stays on the outside, and then this factored down into x minus 3, x plus 3. And so once you have it set up like this, where each of those pieces has an exponent of 1, then I can set each thing equal to 0. 2 is not equal to 0. That doesn't count as any of those asymptotes. So I don't need to worry about that one. I just need to look at the x minus 3 equals 0 and x plus 3 equals 0. And so to solve this one, I'm going to add 3 to both sides. And to solve this one, I'm going to subtract 3 to both sides. So this one's going to leave me with x equals 3. And this one's going to leave me with x equals negative 3. So those asymptotes are x equals negative 3 and positive 3. Okay, so same thing for this function. I'm going to set my denominator equal to 0 and solve. So I start x minus 1 equals 0. I would add 1 to both sides, and that would give me x equals 1. So that asymptote is x equals 1. And so for horizontal asymptotes, we have 3 different cases to look at. And this is something that you're going to want to keep in your notes. This is something that you will have to reference or memorize. So if you remember degree, that's the exponent. And so you want to make sure that these are all set up in standard form first to be able to notice the degree. And so we have when the degree for the numerator, the part on top is greater than the degree in the denominator. And if that's the case, then we end up with no horizontal asymptote. If the degree in the numerator is less than the degree in the denominator, then our horizontal asymptote would be y equals 0. And then if the degree in the numerator is equal to the degree in the denominator, then we do leading coefficient over leading coefficient. And you, again, need your equation to be in standard form in order to take those. Okay, and so this is in standard form, and so I just need to look at those degrees. And so for this one, my degree in the numerator is a 2. The degree in the denominator is a 1. If it does not have an exponent written, remember it is an exponent of 1. And so this is the case for when the degree of the numerator is greater than the degree of the denominator. So we have no horizontal asymptote for this example. Okay, for my next example, that's whenever my denominator, my degree of my numerator is 2. The degree of my denominator is this 4. And so this is the case where the degree of the numerator is less than the degree of the denominator. And so when this is the case, we have a horizontal asymptote at y equals 0. And that last example, that's when we're talking about the same degree. And so the degree of your numerator is 2. The degree of your denominator is 2. And so this is the case of when a degree of a numerator equals the degree of the denominator. And so now we need to look at those leading coefficients. So my leading coefficient of the top is 7, and the leading coefficient of the denominator is 2. And so I'm going to take those two numbers, and it is going to become a fraction. That is my y asymptote, that horizontal asymptote, y equals 7/2. So I will post a supplemental rational functions video in the next week or so, going into more depth talking about these asymptotes on rational functions and things like that and how to find them. So if you have any questions, please reach out and let me know if you need some additional help.